So we are doing kinematics, linear, and 2D motion. Alright, so with kinematics, there are four basic equations that we will use. The first is x equals 1/2 at squared plus v sub o t plus the initial position, x sub o. Also, we have velocity equals velocity initial plus acceleration times time. We also have velocity squared equals v sub o squared plus 2ax. And lastly, we have x equals v sub o t. Alright, with these, we have, so the calculus behind this is just x of t equals 1/2 at squared plus v sub o t plus x sub o. Now to get the velocity in terms of t is the derivative of the displacement. So then you end up getting, when you take the derivative of that, you get velocity equals a t plus v sub o. And we also know that acceleration is the derivative of velocity. So when you take the derivative of the above equation, you just get a. So the acceleration is a, which proves that acceleration is the derivative of velocity. Working backwards, we also know that the antiderivative of acceleration is going to equal velocity. So we can take the antiderivative of a, you get at plus c, and that constant is just going to be v sub o. So you get velocity of t equals at plus v sub o. And then when you take the antiderivative of velocity, you get the displacement traveled. So when you take the antiderivative of at plus v sub o, you get 1/2 at squared plus v sub o t plus c. And that c is going to end up equaling the initial x position. So you get x equals 1/2 at squared plus v sub o t plus x sub o. Alright, so now we're going to talk about the units that are in this section. And we have x, which is in meters. And if you take the derivative dx dt of that, you get meters per second. And then if you take the derivative of that again, which is velocity, meters per second is velocity, you get meters per second squared, which is the acceleration. So now we're going to talk about what each equation is used for. In this, x equals x sub o plus v sub o t plus 1/2 at squared. That is used to find position of of an object in linear motion, and then x equals v sub o t is used to find the range of an object. The v equals v sub o plus at equation is used to find a velocity, and also the v squared is equal to v sub o squared plus 2ax equation is used for the velocity, which is this one right here. Let's do this. Alright, going here. We're doing problem 11, which is a bird accelerating from rest at a constant rate experiences a displacement of 28 meters in 11 seconds. What is its acceleration? Well, we can easily find that using the x equals x sub o plus v sub o t plus 1/2 at squared equation. And simply plugging the values in that we have, we know that the initial velocity is 0, so that cancels out. So is the initial position. So we get 28 equals 1/2 a 11 squared, which gives us a equals 0.462 meters per second squared, which happens to be choice B. Go on again. Try not to grip the pen too tight, break in half. We're back to doing number 19, which is at the top of a cliff, 100 meter high. Raul, my boy Raul, throws a rock upward with a velocity of 15 meters per second. We need to find out how much later he should drop a second rock. In order for them to hit the ground at the same time. For this equation, we're going to use the same equation that we used in the last problem, just a different letter. Y equals y sub o plus VOT plus 1/2 AT squared. First we're going to solve for the rock that Raul happens to throw with an initial velocity of 15 meters per second. For the sake of time, I'm going to skip the algebra, and we know that time it takes for Raul's rock to hit the ground, 6.3 seconds. And the time it takes for a rock that he just simply drops takes 4.51 seconds. So we can easily find how much later he has to drop the second rock by doing 6.3 minus 4.51, which gives us 1.79 seconds, which is choice D. Alright, for the center response question, we have a dart is thrown horizontally towards a bullseye, point P, on the dartboard with initial speed of 10 meters per second. It hits a point Q on the rim vertically below P, 0.19 seconds later. Part A, we're calculating the distance from P to Q. To do this, we have a initial velocity in the x direction
of 10 meters per second, and the time it takes to fall from P to Q is 0.19 seconds. So we can use this equation, y equals 1/2 AT squared, to get the change in y direction. Well, not to change in direction, displacement of the dart. And if we plug in our values, knowing A is 9.8 meters per second squared because of gravity, we get a displacement of 0.176 meters. Alright, for part B, we just have to find how far away from the dartboard do the players stand. To do this, we use the range function. X is equal to v sub o x t, and we have an initial velocity of 10 meters per second, and we know the time it took for the dart to hit the board, 1.19 meters per second. Just seconds. So then we get x is equal to 1.9 meters. That's how far away the guy stood from the dartboard.
While he was juicing.